Welcome back to another Science with Mr. Bois video. Today we're talking about physical versus chemical changes. That's me, Mr. Bois, so let's begin. Whenever I think of physical versus chemical changes, I actually tend to think of cooking. So today we are going to be cooking me an imaginary breakfast and showing how physical and chemical changes apply to that. So we have to start off with, what is a physical change? A physical change is a change in matter that does not create a brand new substance. These are typically reversible, and it's like throwing a big Uno reverse card on whatever type of change you're doing. What is evidence of a physical change? Well, there's shape change, like that lady crumpling paper, or playing with slime and changing the shape of it. There's size change, like ripping up that same piece of paper, or breaking a plate. And then there's state change, which is where you melt ice, because when you melt ice, you're going from a solid to a liquid and overall. But these are the three most commonly found pieces of evidence for physical change. But I really think it's important that right now we take a quick step back and do a quick review or recap of state/phase changes. Now, state and phase changes are basically the same idea in concept. There's a little bit of a difference between them, but for the sake of this video, it has the same idea. So I'm going to use them interchangeably throughout the rest of the video. The definition of a phase change is when matter goes from one state or phase to another. And there are 6 main types. Melting, that's when matter goes from solid to a liquid. Freezing, that's when matter goes from a liquid to a solid. Evaporation or vaporization, they're the same thing. That's when matter goes from liquid to a gas. Condensation, that's when matter goes from a gas to a liquid. Sublimation, that's when matter goes directly from the solid state to the gas state. It skips the liquid phase/state entirely. And deposition, that's when matter goes from a gas to a solid. There is no liquid phase in that. It skips over it. But the big thing here is that the chemical composition of the substance stays the same during each of these phase changes. It's just the physical appearance that changes during them. So what are real world examples of physical changes? This is where we helped me cook my imaginary breakfast. For my imaginary breakfast, I would like to cut an orange into slices. I also would like to slice some bread because we're about to make some avocado toast. And when you make avocado toast, you obviously got to cut an avocado. So I would cut an avocado. All of these things are size changes because I'm not changing the substance itself. I'm just cutting them into smaller pieces so I can make me some delicious avocado toast. The next thing that I would do is I would actually mash or smash my avocado, and that right there is a shape change. I'm just changing the shape of the avocado. And then I would boil some water for my tea because I love a good cup of tea whenever I have some avocado toast. And boiling water is vaporization, and that's a state change. The next step of me making my breakfast actually involves chemical changes. So let's talk about it. So what is a chemical change? A chemical change is a change in matter that means a brand new substance is being made. These changes cannot be undone. So you try to throw that Uno reverse card, I say no. The reason why is because it's significantly harder to undo these changes. It's basically near impossible. So what is evidence of a chemical change? There's actually quite a bit. The first is change in color, heat, light, or sound. You can see this in particular with lighting a match, right? When you light a match, you have a change in light. The room gets lighter when you light a match. There's a flame. And then there's a change in heat. When you light a match, that heat escapes and the room around that match or the area around that match gets a little bit hotter. And the biggest reason why these are considered evidence of a chemical change is that you can't unburn that wick. You can't unburn the match part where the fire was at, right? Hence why it is a chemical change. Another example of this in action or in real life is popping popcorn. When you pop popcorn, you hear a change in sound, right? And you can't unpop a popcorn kernel. Another piece of evidence of a chemical change is a change in odor. Basically, when a new smell is created. I think of baking cookies, and when you bake cookies, your whole house starts to smell, and it smells so good. And you can't unbake cookies, so it's another example of a chemical change. You can also see this when you caramelize or cook onions, right? There's a change in odor, and cooking onions actually has another piece of evidence for a chemical change. There's a change in color, right? Raw onions do not have the same color as cooked onions, and these are examples of chemical changes, especially because you can't uncook onions. The next piece of evidence of a chemical change is actually production of a gas, right? So when you drop a bath bomb into water. But production of a gas does not mean boiling water, because that is actually not production of a gas. No. But you might be asking why? Well, no new substance is being made. Only a phase or state change is happening. And in this particular instance, it's vaporization, where liquid is turning into a gas. That's what happens when you boil water. That's not production of a gas. That's just a phase change in that little GIF right there. But when you put a bath bomb into water, it is a production of a gas because new substances are being made when the bath bomb enters water. The next evidence of a chemical change is formation of a precipitate. Now, what is a precipitate? Basically, it's when two liquids combine together make a solid. Right there is an example of it because that yellow stuff that you see is actually solid formed by the liquids. The final piece of evidence of a chemical change is a change in pH. This is basically a change in how acidic or basic something is. There's a pH scales and there's a couple of ways to test it, but it's not really relevant for this video, so I'm just going to move past it. Now let's apply this to my breakfast scenario. Here we have a GIF making toast, and when you make toast, there's a change in odor, there's a change in color, and you can't uncook toast. So let's have all of this combined together and you see my breakfast, and voila, that's me making breakfast. And that's on physical versus chemical changes. And I'm Science with Miss Dubois. I hope you enjoyed the video.